All right, so now with the black background, and I'm just checking if my microphone works, we will continue on drawing linear absolute functions. So let's do a couple of practice examples. Let's do the first one. So first one, let's say that you get as a problem x minus 3 plus 4. Now notice, I have numbers or coefficients in two locations, both inside the bracket in blue and also outside the bracket. So let's recall what happens to each one of them. This one outside the bracket shifts the function towards the positive y direction. And here in the blue, because it's inside and because it's negative, shifts, and I will use the more scientific term, translates. And no, it's not the English translation, it's a physical translation. Translates the function in the positive x direction. So we can calculate where the point is. Now, a very, very quick vocabulary check is that this point right here for the up and also downwards, which we'll calculate in the next video, is called a vertex. This point and this point is simply, we can call it a vertex. For me, a description, I like to call it as an important point, or describe it as an important point that describes our function. So let's go on and draw a coordinate system, right? Let's draw it right here. So we have our x-axis, we have our y-axis, and now we have to find where that point is. So let's draw, just for reference, I'll use a yellow, a traditional absolute value of x. So this function is the absolute value of x. Now, let's go with the blue one. The blue translated this in the x direction in a unit of 3. So let's go just 1, 2, 3. So 1, 2, 3. And I'll draw, I'm drawing it step by step, okay? So also here, 1, 2, 3. And the function should look something like this. Okay, here's the function after we translate it by the minus 3. However, I want the whole thing, and the whole thing will be drawn in a green. From this point right here, we have to shift this point upwards by 4. So right here, here's the translated vertex or the shifted vertex, and I might go through the text, so I'm sorry. So the final graph looks something like this. This is the final graph right here. Let's try a couple more. Y equals absolute value x plus 5 minus 2. So again, let's visualize. And we have a way of calculating where the vertex is simply by looking at this number inside the bracket, so the blue number, and this number, which is outside the bracket. The vertex point, the vertex of our absolute linear equation, again, remember these are coordinates, so the first one is x and the second one is y. Now the question is which? Plus 5 means that our vertex point will be at minus 5, shifted towards the left. And then y means that minus 2, well, we simply put minus 2. And I'm trying to find my green. minus 2. So the vertex is minus 5, minus 2, and you can visualize this as some kind of point. So I'm going to draw a nice big coordinate system as so. X and Y. And again, I don't need to put ticks everywhere. I need 1, 2, 3, 4, 5. This is minus 5 for now. And 1, 2. This is minus 2. And we draw a point or our vertex at this location. And now I need minus 3. And I also need minus 7. Now, why do I need these numbers? We know, let's try to plug in, for example, if we would go with the coordinate table method, let's try plugging in minus 7 into this function. Minus 7, if we plug in, we get minus 7 plus 5 minus 2. This is equal to minus 2 minus 2. Now, very careful. We have the absolute value, which then equals to 2, and this equals to nada or 0. In other words, the point is right here, which makes perfect sense. And I promise you that it's symmetric. And because it's one of the properties of absolute functions is that it's symmetric. And the final function, which again I can draw in a nice green color, is something like this. Going up. And let's say I want to write down exactly this point, so the y-intercept. Let's give it a red. So this point. What is the value? What is the y value of this point? And let's just call it, I don't know, a y comma. We continue as we usually did, is that I am plugging in the number x equals 0. So x equals 0. Let's plug in into our function right here for our x, which then, if we plug in 0, 0, 0, plus 5, minus 2, and it's simply equivalent of 5 because, well, what's the absolute value of 5 is simply plus 5, minus 2 is 3. So this point right here, if drawn perfectly, it is exactly in 1, 2, 3 ticks. And this is our final function that is correctly drawn right here.